All right, welcome back. I know you guys understand that we have gone a little bit out of order here. We went over and did 4.6. The reason why I wanted to do 4.6 before jumping back here is I wanted you to know all possible ways to prove that two triangles were congruent before we moved on to this section. Section 4.4 is called CPCTC. CPCTC. All right. The start thinking will guide you into understanding what the heck that is. The start thinking says you are given the following information about triangle ABC and about DEF. You are told that they are congruent. You also know that measure of angle A is 50. You know that D is 2x. What does x equal and how do you know this? Well, how could you do this? We have A and we have D. Oh, take a look. Angle A and angle D are all both in the same location with this congruent statement. Therefore, we know they are congruent. So we know 50 must equal 2x. 50 must equal 2x. Okay, and you would get x equals 25. So if I asked you to explain how you knew that, you might say, oh, it's because corresponding parts of congruent triangles must be congruent. Ta-da! That is basically what this whole section is about. It means that if you can prove two triangles are congruent, you know all of the parts are congruent. So once again, here's the theorem. If two figures are congruent, then their corresponding parts are congruent. Now, a real world example of this. I went over and scratched up the back plastic inside of my 2015 4Runner. I'd really like to go to a junkyard, find a 2015 4Runner, and then go over and pull the parts out. Why am I able to do that? Because I know that if the two 4Runners are congruent, if it's truly the same make, model, and year, then all of the parts should also be congruent. So I could say corresponding parts of congruent 4Runners, corresponding parts of congruent 4Runners are congruent. I could do that as well. It's basically saying if you know the whole object is congruent to another whole object, then their parts must be congruent. Now, it's basically doing normal proofs with one last step. So how do I know that I'm going to finish with CPCTC? Take a look. The end here does not state that I'm supposed to state or show that two triangles are congruent. I'm supposed to show that two angles are congruent. That gives me a little bit of information and gives me insight that I am going to be first showing the triangles are congruent, but the final step will be showing that the angles are congruent by CPCTC. So let's go ahead and do this. If I said that AB was congruent to AC, cool. M is the midpoint of BC, so those are congruent. That's just two ticks. And then I could use the reflexive property to show these were congruent. Now I would be able to say that the two triangles were congruent by SSS, and then you would put one last step in and say their angles are congruent by CPCTC. I know the triangles are congruent, so all their parts are congruent. Let's go ahead and make the proof. Statements, reasons. AB is congruent to AC, which I know is given. There's nothing that leads to, it's a standalone. Then we have M is the midpoint of BC. That's also given. However, I have to use it right after I state it. So if M is the midpoint of BC, then we know BM is congruent to MC by definition of midpoint. I now have an S and I have another S. My last S is going to be that MA is congruent to MA by the reflexive property. Now here is the only confusing part about this. Normally it tells you the order that you are going to be listing your points when you're talking about the two triangles. Now we have to be careful with it. We now have to do it on our own. Triangle BMA is congruent to, I decided to start at B and then I went counterclockwise, BMA. Now that is congruent to triangle. B on this triangle is what point on the other, or what vertex? C. M on the top triangle is what on the bottom triangle? M. A on the top triangle is what on the bottom triangle? A. So now I would state the two triangles are congruent by SSS. And then one last step. All we do is say angle AMB is congruent to angle AMC by CPCTC. I figured out that the triangles were congruent. And then I have one last step that just says, hey, now that I know the triangles are congruent, these two angles are congruent. Another example could be if you had an identical twin that was perfectly identical to you, and your twin went to Target with your mom, and your mom was like, hey, I want to buy this shirt for my kiddo who's at home, but I don't know if it fits them. Well, since we know that the two twins are congruent, we know their parts are congruent. So that means if a t-shirt fits one of them, it should fit the other one if they were perfectly identical twins. So first go over and prove the things are congruent, then you know the parts are congruent. So their heights are congruent, their arm spans are congruent, their shoe size is congruent, and so on. Probably makes a little bit more sense when I was talking about my forerunner. If I can go over and do some kind of proof to show that the two forerunners are congruent, then I know all their parts are congruent. I can take the alternator of one and put it in the other, and so on. So really, once again, this is just practicing proofs. It's a normal proof like we've been doing, then you add one step. So on this one, it says that L is perpendicular to AB. Gotcha. Then it says L bisects AB at C. If it bisects AB at C, then these must be congruent. And then what else do we, P is on L. Okay, well, I could go over and use the reflexive property. Now, would I use these right angles to be congruent angles, or so I can use HL? Well, it looks like it's an SAS, so I want to say the angles are right, therefore they are congruent. So let's go ahead and do it. L is perpendicular to AB, given. Then angle ACP and angle PCB are right angles. And that would just be definition of perpendicular. How do we use these? Are they congruent, or are we stating that the triangle is right so we can use HL? Well, since we're using SAS, we care about them being congruent. And that is all right angles congruent. Okay, now I'm going to state that L bisects AB, which is given. So that means AC must be congruent to CB, def of bisect. So now we have an A, we have an S, and then my other S for the SAS is going to be PC is congruent to PC, reflexive, prop. That's my other S. So now I have to state the two triangles are congruent. Triangle ACP is congruent to triangle, I'm going to make sure that the corresponding parts match up, BCP. That's by, what is that going to be? That is going to be SAS. I'm just going to put little lines over these just so that it's a little bit easier. So now we know that PA, a part of one triangle, must be congruent to a part of another triangle. by CPCTC. There we go. Okay. All right. Now let's move on. On this one, I know I'm going to be ending with CPCTC because they want to know sides are congruent, not that the triangles are congruent. So I am going to do a bunch of shenanigans. I'm going to show a triangle is congruent to a triangle by something, and then I'm going to show the side is congruent to the side by CPCTC. I just need to figure out how I'm going to do this. Well, we have angles congruent to angles and angles congruent to angles. What else do we need for this proof? What other thing from our toolbox are we going to use? We're going to use the reflexive property. Once we know the two triangles are congruent, we're going to use CPCTC. So angle ABD must be congruent to angle CBD, and angle BDA is congruent to angle BDC because it's given. Since neither of one of those are like leading to something else, I can clump them together to one given. I then know that BD is congruent to BDY, reflexive property. So now I have to list out the two triangles that are congruent. Triangle ABD is congruent to triangle what? A going to B, then D is the same thing as C going to B, D, CBD by ASA. And now I can just state that AB, which is a part of one triangle, must be congruent to CB, part of another triangle, by CPCTC. There you go. That's all these proofs are. You go over and you state the two triangles are congruent, and then you can state that the parts are congruent. So let's go over and do one or two more proofs. So now it gets a little tricky. So let's say we are looking at this. We wanted to show, basically we have to figure out what two triangles we're going to work with. We have this triangle and this triangle, or we have that triangle and that triangle. Now, with what we are trying to solve, do we have any hints about which ones we're going to be working with? Not really, because MN and QP could be with this triangle and this one, or the overlapping. So we're not 100% sure which ones we're going to be doing. We can either prove these two triangles are congruent and then use CPCTC, or we can do the overlapping triangles. Let's figure out which ones we're able to work with. If I wanted to work with this one and this one, we already have that those angles are congruent. We have the vertical angles theorem. Do we have anything else? MO is congruent to OQ. Oh, awesome. So those are the triangles we're going to want to work with, not the overlapping ones, because now we have A, S, right? Let's see if we would have been able to work with the overlapping triangles. So for these two triangles, we would have that, and we would have this one. Well, they have the reflexive property. They have this angle is congruent to that angle, but this is not a full side of those big overlapping triangles. And this right here is not a full side. So we wouldn't have worked with those. Let's go ahead and work with this triangle, this one. Let's start with the given. Angle N is congruent to angle P. Given. MO is congruent to QO. Given. Now what else do we have? Vertical angles theorem. angle MON is congruent to angle QO. Don't know what that is. QOMNO. It's got to be a P. By the vertical angles theorem. Now we can state the two triangles are congruent. Be careful with your order. MNO is what I'm going to say. So now we have to be careful with the second one. M corresponds to Q. N corresponds to P. And O corresponds to O. I'm hoping that that right there is a P. And that would be by AAS. And then we would just state that the MN, a part of one of the triangles, is congruent to QP, which is a part of the other, by CPCTC. Show the triangles are congruent, then state that the parts are congruent. Okay, let's look at this last set of triangles here. CT, actually, let me see what the real last problem is. Let's go ahead and do this one. This one is obviously prove the two triangles are congruent, and you have the vertical angles theorem, so you have ASA and then CPCTC. This one would be a pretty easy proof. Let's just look at this last one, which is kind of funky. All right, in the end, I want to show that E is congruent to F. So it looks like in the end, I want to show that that triangle is congruent to that triangle, right? Well, let's see if we can work with those two triangles right off the bat. We know that BD bisects ABC. We know that BD bisects ABC, so those angles must be congruent. We also know that BAD is going to be congruent to BCD. It's weird. Why are they talking about those triangles? We know in the end we have to be working with those bottom left and bottom right. We also know that AE is congruent to CF, and we know that ED is congruent to DF. So let's say we wanted to work with, let's just try to jump straight to these triangles. Can we prove those are congruent? Well, we have the S and the S, but we don't have anything else. Don't think we can work with those triangles first. What about if we work with these two triangles and somehow use that? Can I prove that those two triangles are congruent? Well, we have the A, and then we have the reflexive property. If we have that reflexive property and AA, then the two triangles are congruent by AAS. Now, why would we want to know that, though? Now that we know the triangle is congruent to the triangle, how could we use that? Oh, then we can do CPCTC to do those being congruent, and now we can go over and work with these two triangles. That makes sense. So we are going to work with, and I'll try to draw it out for you. Let's first prove that this triangle is congruent to the triangle right next to it. Let's do that first. So if we said BD bisects angle ABC, which is given, that leads us to be able to say angle ABD is congruent to, that's a B, ABD is congruent to angle CBD by def of angle bisector. Okay, what else did we have for those two triangles? We now know that this is congruent to that. Maybe let's do the reflexive property. BD is congruent to BD, reflexive prop. Okay, I know that those are congruent. We also know that these are congruent because it's given, so angle BAD is congruent to angle BCD given. Okay, now let's state those two triangles are congruent. Triangle ABD is congruent to triangle CBD by AAS. Now, what parts of these two triangles will help us with triangle 3 and 4? I named this 1 and 2, so 1 is now congruent to 2. What parts of 1 and 2 help us with 3 and 4? It would be the fact that AD is congruent to CD by CPCTC. Now I'm going to state the other givens I want for those two triangles. That would be that AE is congruent to CF, and also that ED is congruent to DF. Those are both given, which now tells us that triangles are congruent. Triangle ADE is congruent to triangle ADE CDF by SSS, and therefore angle E, go ahead and do this, angle E is congruent to angle F by CPCTC. So this was the mother of all proofs. This said that we had to work with these two triangles first so that I could learn more about the two triangles that in the end I want to work with, because I didn't have enough information about those. And then finally, when I could prove those triangles were congruent, I showed those angles were congruent. So this is a huge proof. You might be asking, why didn't you just state these givens up here? Well, I like to state givens when I'm going to be using them. These are not used until we're talking about triangle 1 and 2. That's why I waited. So once again, work with two triangles, then parts of those triangles will help us with other triangles, and then we can finish it. All right, hopefully you enjoyed the mother of all proofs. Remember, CPCTC just means corresponding parts of congruent triangles are congruent. All right, once you prove the triangles are congruent, then you can state that their parts are congruent by CPCTC. It's basically everything we've already done with one extra step. Let me know if you guys have any questions.